Welcome back to the deep dive, where we take these deep dives into some pretty complex topics.
That's right.
Today is no exception. No exception at all.
Nope.
We are going to be looking at quantum support vector machining, or QSVMs.
QSVMs, yes.
And we're going to be taking a look at this through the lens of Jörg O. Schneppat's essay, Quantum Support Vector Machining QSVMs, Next Generation KI.
It's dense.
Yeah, it's a fascinating essay.
Yeah.
It's really interesting.
It really is.
So, let's just dive in, I guess. What are these things, and why should we even care about them?
It's an area with incredible potential, and I think Schneppat does a fantastic job in this essay of really laying out the groundwork. And he does this kind of surprisingly by first explaining the history of classical support vector machines.
Yeah. He doesn't just jump right into the quantum realm.
No, he does.
He spends a good chunk of the essay talking about how SVMs kind of came to be.
Right.
And he highlights this thing called the kernel trick as a real pivotal moment in the evolution of SVMs.
For sure.
Can you break that down for us a little bit? What is that?
Yeah. So think about SVMs as just really clever algorithms that draw boundaries to separate different kinds of data, right? So you've got your data points, and you want to be able to say, okay, these belong over here, these belong over here. The kernel trick is this really clever mathematical technique that basically allows SVMs to do that in higher dimensions, right?
Okay.
So it makes them much more powerful for these very complex problems. And Schneppat argues, I think convincingly, that this was just a total game changer for the field.
Okay, so that sets the stage for the classical side of things.
Yeah.
And now I'm really interested in how Schneppat brings quantum mechanics into the picture.
Well, that's where things get really interesting.
Yeah.
He does that by first introducing, the basic building blocks of these quantum computers.
Mm-hmm.
Qubits, right?
Right.
And so unlike the bits in your computer, which are either 0 or 1 qubits, they can be in this weird fuzzy state. This is called superposition.
Right.
And that means they're both 0 and 1 at the same time.
Right.
It's kind of mind-blowing.
Yeah, and then there's entanglement.
Oh, yes.
Which is even more mind-blowing,
Yes.
which is, this spooky connection between two qubits.
Right. And Schneppat doesn't really dwell too long, thankfully, for our brains on the, nitty-gritty of the quantum mechanics. But he uses it to highlight just how incredibly powerful quantum computing can be. He brings up things like Shor's algorithm.
Right.
That's for breaking encryption.
Yeah.
And Grover's algorithm for super fast searching, just as two quick examples.
Right. So we've got these SVMs for classification on the one hand.
Yes.
We've got these kind of mind-bending quantum algorithms on the other.
Right. Right.
How does Schneppat bring these two worlds together?
Well, that's where QSVMs come in. They essentially try to marry, the power of those SVMs with those really, really unique capabilities that these quantum computers offer.
Okay, so how's he doing that?
What's fascinating, I thought, is that Schneppat describes QSVMs as, projecting data into this thing he calls a quantum feature space.
Hold on.
I know.
Quantum feature space.
I know.
That sounds like something straight out of Star Trek. What does that even mean?
I know. It's a really evocative phrase, isn't it?
It is.
But it's essentially a way of representing data in a space that has dimensions that we can't even really visualize, It's like taking a 2D shadow of a 3D object,
Right.
But on this grander, more complex scale. And this allows those QSVMs to find patterns and relationships in the data that would be completely invisible to classical SVMs.
So Schneppat seems to suggest that this could be the key to unlocking insights from these really complex data sets, stuff that we couldn't even begin to analyze with classical computers.
Yes, absolutely. And he gives several examples of, some of the potential benefits. And I think he does this really well. He really highlights, first of all, the speed advantage, right?
Right.
So QSVMs could potentially perform those calculations exponentially faster than classical SVMs for certain types of problems.
Really?
And he also suggests that they could actually handle problems with a level of complexity that would just choke even the most powerful supercomputer we have today.
Okay.
So it's pretty exciting stuff.
Yeah, he paints a pretty optimistic picture of QSVMs.
He does.
But I'm guessing it's not all smooth sailing.
Of course not.
There have to be some challenges here.
Oh, yeah.
Right.
You're absolutely right. Schneppat doesn't shy away from the limitations. He emphasizes that we're still very much in the early days of quantum hardware.
Right.
And QSVMs, they need a lot of stable qubits to function properly, and those are really hard to build. They're hard to control.
So is it kind of like having the blueprint for a supersonic jet?
Yeah.
but we're still figuring out how to make the engines work?
That's a great analogy. That's a really good analogy.
Yeah.
Yeah. Schneppel actually goes into quite a bit of detail about the specific hardware requirements, right? So the number of qubits, their stability, which he refers to as coherence time,
Okay.
and the need for just incredibly precise control, right?
Okay.
He even points out this is one of the biggest bottlenecks for the field right now.
Right.
And, it's not just about building the qubits themselves. There's this pesky issue of decoherence.
Right.
Which Schneppel goes into some detail about,
Yeah.
where qubits lose their quantum properties over time.
So even if we manage to build a quantum computer
Right.
that's got enough qubits,
Yeah,
it might not be able to do anything useful because
Yeah.
the qubits just lose the information too quickly.
exactly. It's like trying to, write on a whiteboard that keeps erasing itself.
Right. Right.
It's really frustrating. And then you've got the problem of errors,
Uh-huh.
creeping into the calculations.
Right.
So Schneppel stresses that error correction is a huge area of research right now.
Right.
It's crucial for making quantum computing actually reliable.
Okay, so it sounds like we've got a long way to go
Redo
for
it.
QSVMs are
Yeah.
really practical.
Yeah.
But I sense a but coming.
There is a but. Schneppel is actually quite optimistic about the future.
Okay.
He points to the rapid pace of innovation in quantum computing. New types of qubits are being developed all the time
Right.
that are much less prone to those errors.
Okay.
And researchers are coming up with really clever ways to combine classical and quantum computing
Which,
to get the best of both worlds.
so you're saying we might not need to wait for a perfect quantum computer
Exactly.
to start seeing some of the benefits of QSVMs.
That's what Schneppel suggests.
Okay.
He talks about these hybrid algorithms that use classical computers to handle the parts of the problem that don't require quantum mechanics.
Right.
And then they hand off the heavy lifting to the quantum computer when they need to.
Interesting.
Yeah.
So it's not an all or nothing situation?
No.
We can start experimenting with QSVMs now,
Yeah.
even with the limited quantum hardware we have.
Yeah.
That's very cool.
And another thing that Schneppel highlights is this development of these cloud-based platforms
Right.
that are democratizing access to quantum computing.
Yeah.
So this means that researchers and developers can access these powerful quantum computers without having to actually build their own.
So is it kind of like the early days of the internet where you didn't have to have a giant mainframe to actually
Yeah.
tap into the power of computing?
Exactly. That's a perfect analogy.
Okay.
Schneppel argues that this is accelerating research and development in quantum computing, which will ultimately benefit the development of QSVMs.
Okay, let's shift gears a little bit.
Sure.
Schneppel spends a good portion of the essay talking about the potential applications of QSVMs.
He does, yeah.
What are some of the areas that he seems most excited about?
Well, he covers a really wide range from, drug discovery to materials science to finance even.
Okay.
In biotech, for instance, he suggests that QSVMs could analyze massive genomic datasets to personalize treatments, or even help design new drugs by predicting the 3D structure of proteins.
So instead of blindly testing thousands of compounds,
Yeah.
we'd use QSVMs to figure out which ones are most likely to work.
Precisely, and much faster.
Okay, cool.
He also sees huge potential in materials science.
Mm.
He talks about using QSVMs to design new materials with, very specific properties like super strong alloys or incredibly efficient solar cells.
That's pretty amazing.
Yeah,
It sounds like QSVMs could really revolutionize entire industries.
absolutely.
What about finance? What applications does he see there?
Well, he envisions them being used to manage risk in these complex financial markets, detect fraudulent transactions much more efficiently, and maybe even make better investment decisions by analyzing huge amounts of data.
It's almost like giving financial analysts a superpower.
Kind of is.
But with all this talk of potential benefits,
Yeah.
I'm wondering if Schneppel addresses any concerns about the ethical implications
does.
of QSVMs.
He touches on the need for responsible development and transparency in how these algorithms are designed and used.
Right.
After all, QSVMs are really powerful tools, and like any powerful tool, they could be misused.
Right. Just because we can do something doesn't mean we should.
Exactly.
We need to think carefully about the potential consequences.
We do, and Schneppel reminds us that, we're still very much in the early days of QSVMs. We're just beginning to explore their capabilities and understand their limitations.
So it's a time of both great excitement and great responsibility.
I couldn't agree more.
Okay, we've covered a lot of ground here.
We have.
What are your personal takeaways from Schneppel's essay? What really stood out to you?
For me, it's the sheer transformative potential of this technology. Schneppet's essay really drives home the fact that we're really on the cusp of a new era in computing and data analysis.
Yeah.
It's a time of incredible opportunity, but also great responsibility, as we've been saying.
I totally agree. And it's not just about the technical advancements themselves. It's about what those advancements allow us to do.
Right.
Schneppet makes a very compelling case for QSVMs as this tool to tackle some of the world's most pressing challenges.
Absolutely.
Disease to climate change.
Yeah. And he really underscores the importance of human ingenuity and collaboration in driving this progress.
Right.
It's not just about building faster computers. It's about asking the right questions and working together to find solutions.
Well said. Now, let's say someone is listening to this and they're feeling inspired by this.
Okay.
What advice would you give them if they wanted to learn more about QSVMs or even contribute to the field?
Well, first, I would recommend reading Schneppet's essay in its entirety.
Of course.
It's a fantastic starting point. He provides a really comprehensive overview of the topic and includes a very extensive bibliography for further exploration.
Great.
Second, I would say dive into those fundamentals of quantum computing and machine learning. There are tons of online resources and courses available. Okay. And then finally, don't be afraid to experiment. Cloud-based platforms like IBM Quantum Experience and Google Colab allow anyone to run quantum algorithms and play around with QSVMs without needing their own quantum computer.
Because it's kind of like having a virtual quantum laboratory at your fingertips.
Exactly. And don't underestimate the power of community. There are online forums, meetups, research groups, and even online courses where you can connect with other people who are excited about quantum AI. It's a great way to learn from others, share your own insights, and just stay up to date on the latest developments.
It really is. And it's so accessible now for anyone who really wants to get involved. So that's really exciting.
It is a really exciting time to be involved in this field. It's like being present at the birth of a new scientific revolution.
Well said. So where does all of this leave us?
That's a good question.
We've explored the power of QSVMs,
the
challenges that lie ahead, and some of those ethical considerations that we really need to keep in mind.
Right.
It's a lot to process.
It is.
But I think Schneppet's essay really does a good job of offering a valuable roadmap for how to navigate this uncharted territory.
I think that's a great way to put it. It's a roadmap.
Yeah.
He doesn't just, present the facts and figures. He really invites us to join the conversation, to ask those tough questions, and to really imagine the possibilities.
He even challenges us to think about how QSVMs might change the world in ways that we can't even really fathom right now.
He does. It's really thought-provoking.
It's like he's handing us a telescope and saying, look up at the night sky and imagine what's out there.
That's a beautiful analogy. I love that.
It is a beautiful analogy.
Yeah.
And Yorgos Schneppet's essay does exactly that. It opens up our minds to the vast possibilities of this technology.
Yeah.
But at the same time, reminds us of our responsibility to use it wisely.
Yeah, I think that's one of the most important takeaways from our deep dive today.
Right.
It's easy to get caught up in all the hype surrounding quantum computing and artificial intelligence, but we need to remember that these are powerful tools, and they can be used for good or for ill.
Schneppet doesn't shy away from those ethical considerations.
He doesn't.
He really challenges us to think about the potential consequences of this technology and to make sure that it's developed and used in a way that benefits all of humanity.
Right. It's a call to action for all of us, whether we're, researchers, developers, policymakers, or just concerned citizens. We all have a role to play in shaping the future of quantum AI.
So for anyone listening who's feeling inspired by this conversation or maybe even a little overwhelmed by it, where should they go from here? What would you say is that first step they should take?
I'd say the first step is to read Schneppet's essay in its entirety. It's a beautifully written piece. It's really thought-provoking, and it'll give you a much deeper understanding of the potential and the challenges of QSVMs.
And we'll, of course, provide a link to the essay in the show notes so you can easily find it.
Perfect. From there, I would encourage everyone to explore some of those resources that Schneppet lists in his bibliography. There's a ton of information there on quantum computing, machine learning, and the intersection of the two.
And don't forget the power of community.
Oh, yes, definitely.
There are online forums, meetups, research groups, even online courses where you can connect with other people who are passionate about quantum AI.
Yeah, it's a great way to learn from each other, share your own insights, and stay up to date on the latest developments.
Well said. And to echo Schneppet's sentiment, If you're fascinated by this fusion of quantum mechanics and AI, keep a close eye on QSVMs. They might just reshape our technological landscape in ways we can only begin to imagine.
It might just change the world.
That's it for this deep dive into the world of QSVMs. Thanks for joining us on this journey into the quantum frontier. Until next time, keep exploring, keep questioning, and keep imagining the possibilities.